Okay, now let us continue with topic 5, practical 3, question 3. Okay, so let's read out the question. The question asks us to use the auto data set, develop a logistic regression model to predict whether a given car gets high or low gas mileage. Okay, in part A, we are asked to create a binary variable mpg01 that contains 1 if the mpg has a value which above its median and 0 if it's not. Okay, so first let us load the library which contains the auto data. Okay, so we are asked to construct mpg01. Okay, here mpg01. Okay, from mpg. Okay, if it's larger than the median, okay, then we set it to be 1, otherwise 0. Okay, we are using the else if else command, okay, which is very powerful in this case. Okay, and that's all. Okay, to the solution of part A. Okay, now let us look at part B. Okay, we are asked to explore the data graphically in order to investigate the association between mpg01 and the other features. Which of other features seem most likely to be useful in predicting mpg01? Okay, and we are asked to describe our findings. Okay, so for this we'll be using the correlation function from R. Okay, but in order to do that, we have to remove the 9th column. Okay, so once we enter, we can see that all the values are more or less the absolute value of them are larger than 0.7. Okay, except for a few. Okay, so in order to have a better visual perception, okay, we run the pairs. Okay, so we can basically find that over here, okay, there seems to be some kind of either this one is inversely correlated or positively correlated. Okay, so yeah, okay, so then we would continue to use the absolute value, okay, and then check whether it's larger than 0.75, okay, to see whether which variables are correlated. And okay, from here we can more or less see, okay, cylinder displacement, horsepower, weight, okay, all of them are strongly correlated to mpg. Okay, therefore in some sense it's related to mpg01 because mpg01 is actually created from mpg. Okay, so that's why I put this thing up, okay, as part of the answer. So cylinder, weight, displacement, horsepower, okay, all of them are correlated to mpg and hence mpg01, right? Okay, so because of this, okay, in part C, okay, when we're asked to perform the logistic regression on the training data in order to predict mpg01, okay, try our different combination of variables and test our models with validation data. What is the best fitted model? Okay, we will find that, well, it's basically just taking these 4, okay, and put it in the model. Okay, that's why you find that I have the mpg01, okay, related to the 4 correlated or inversely correlated variables. Okay, but first we need to set up the training and testing data. Okay, so now is question 3C. Okay, so let's set up the training and testing data as mentioned just now. Okay, and then we set up the logistic regression model. Okay, the command here is just to show the formula of the model. Okay, you can see this is the formula. Okay, similar to earlier examples. Okay, we use the predict function. Okay, and use if-else statement. Okay, sorry about highlighting. Okay, to actually classify the testing data. Okay, finally we will be using the table, okay, to construct a confusion matrix. Okay, you can see a confusion matrix here. Okay, apparently okay, the diagonal is a very high value, so we believe that the accuracy is going to be very high. Okay, and the model is quite successful in carrying out prediction for our data. Okay, and indeed, okay, based on some simple R commands, we can estimate out that accuracy is more than 90%. Okay, and then the error rate is very low. Okay, recalls and precisions are very high. Okay, I think everyone can see that I did not perform set seed. Okay, so at home you can probably perform set seed equals to 1. Okay, and compare your result with your friends' results. Okay, otherwise all of you, despite the same command, will be getting a different answer from mine. Okay, that's all for the solution of practical 3, question 3.